Oh, hey, this is rather loud today. Okay. All right, sorry if I gave anybody a heart attack there. How's everybody's weekend been? Good? It's going to get cold this weekend, so, just keep that into account. Now, all right, as a general reminder, your exam is not today, not Thursday, but next Tuesday. Next Tuesday. It will be in here. It will be on paper. All on paper. Okay? So, I should have the exam hopefully written tonight or tomorrow night, depending on how things turn out. So, I'll be able to give you more hints about it. But honestly, it's going to be very similar to the practice exam. Okay? I'm going to work on... All right. So, what we're going to do today, what we're going to do on Thursday is that I will go over the practice exam in class. So I'll go over that on Thursday. Please be sure to check it out because I do design some of the plenty of the questions on the exam as learning experiences. So be sure to realize that. Also be sure to work on the turtle homework because that's relevant towards the exam. And finally, for today, we will be working on 2 in-class exercises. We'll be continuing the password one. And again, this is something to upload, and we'll do yet another one to upload after we're done with this one, since we started this one, but let me go ahead and review it. All right? What we were reviewing is that password generation is terrible. If we go to our password, let's go to accounts.temple.edu. Just for a second. Okay, log into Sure. Log in here to change your passwords. All right, let's go in here. Loading, please wait, blah, blah, blah. You can change one of the following, your password, which is not about to expire, blah, blah, blah. I'm probably breaking something by putting this online or something. Who knows? I agree with policies, and it is a violation to disclose their own password to anyone, so please don't tell anybody my password is 12345. Okay. All right, so notice that basically I really enjoy, so the policies for Temple make actually a lot of sense, which is that you cannot reuse your last 3 passwords. You cannot use certain words like Temple in your password for Temple. Okay, and your password length is up to you as long as it's at least 8 characters long. The requirements for the password vary by length. So if you're going 20 or more characters, you're allowed to type in whatever you want. Any combination of US keyboard characters. If you have 16 to 19, you need uppercase and lowercase characters. So that's actually pretty easy because you can just pick like 4 or 5 random words, 3 to 5 random words, and string them together, and suddenly you've got an easy-to-remember password. But if you're going for a short password, you need the whole uppercase, lowercase numbers, and symbols, right? Use 4 more unrelated words, such as correct horse battery staple. Gee, I wonder where they got that from. So, if you're unfamiliar with this comic, by the way, it's called XKCD. XKCD, which doesn't stand for anything really. So leap smearing. Why do clocks say it's 3 a.m.? Adding an extra day creates too many glitches. Instead, we're just running our clocks 34% slower during February to avoid the irregularity. This year, Google has expanded their second leap smearing to cover leap. So yeah, and there is a lot of this gets into the whole. I'm going to get into this today with that time is a really weird, and different companies have different way. Like Google has a different way of has their own way of managing time called leap smearing. It is just, but anyway, there's all sorts of just comics over there, but you get a lot of tech-based comics here. Some are mildly not safe for work, but I mean stick figures, so they might discuss things that are not safe for work. So anyway, so let's go ahead and just review this code. So we imported random. We have our letters, our capitals, and our numbers. These are basically all the things you'd pound on the keyboard to get something. You might decide to also do symbols as well. That's not that hard to add. No need to add this as well. By the way, I was able to just load this back up because it saves your history in this thing, which is really cool. So symbols like right, and then I can just add that into the options as well. And remember, what this does is that this takes all these strings over here and glues them together into one big mega string, one new big mega string, right? Called options. Okay, and then what we do is that we I don't know why we have a random print over here. We have our password, and what we do is that we do something called an accumulation pattern. A pattern is something we see a lot, right? A basic pattern is like this, for blank in range, where if we want to repeat something a bunch of times, that's a standard for loop. An accumulation pattern adds on to the for loop, which basically says we start out with something like 0, okay, and then we basically add a letter to our existing password. So password is equal to password plus letter. I just simply rewrote that. It's the same thing as what I just had earlier. So basically we take what we already have for our password, add the letter onto it. Then each letter on it, and the letter is a random choice from all these options, right? So we take one letter out of randomly out of our mega string and add it to the end of our password, right? So for this one, it randomly chose G as the first letter. Then it went letter is equal to random.choice. That's a capital E. So then we took our password, which was lowercase g, and then it added the uppercase E, right, to the end of it, and then it added the uppercase L, right? We can print it out step by step. Okay, save and run, right? It did 88888L, 88LE, 88LEF, L, right? It just simply picked one at random each time. Okay, but these are not easy to remember, and they're very easy to break because they're short. So now let's take a look at these lists of nouns, verbs, and adjectives. So make a 4-word password by combining words from the list of nouns, verbs, and adjectives. And I'm going to go ahead and get you started by reminding you, because really it's the same code as you were using over here. So let's just go ahead and remember, let's import random, because you're going to need to randomly choose stuff. And the great thing about Python is that sequences pretty much can be used the same way. So we can do a lot of the same of what we were doing over here. We can say options, the list, right? It's a list of words rather than a string of characters. So we can just combine them into one mega list by saying nouns plus verbs plus adjectives, and this concatenates it all together. Right? And see, now it's one mega list. So now use this. So now, with this, make a 4-word password by combining the words from the list of nouns, verbs, and adjectives. Okay? And you want to basically take what's over here and adapt it. So go ahead and work on that, and then we'll move on to the next part. Okay? So go ahead and take a look at that. This exercise shouldn't take that long. It's a fairly straightforward exercise. You're just taking what you want and you're adapting it. And because there's so many words and stuff, I highly recommend actually doing it in the textbook if you can, because you've got this list of stuff all these list of options over here. You can, of course, do your own list of options if you want to, if you're just doing it on your local computer. You can make up your own word like apple, banana, run, grab, jump, and then busy, lovely, awesome. I had to use positive adjectives so you can feel good about yourself. We're all in need of positive reinforcement and self-love. right, I'll wait a couple more minutes, and then I'm going to put the answer on the screen. And please, there's no need to work on it silently. Please go ahead and bother the person next to you and ask them if you need help. Please, I want this to be a collaborative experience. Get friendly with your neighbors. Remember, if you don't have a laptop, just simply get friendly with somebody who does and ask them to send it to you the code later after you work on it together. That's better. It's not often your professor asks you to talk during class. All right, people need more time on this? All right, I'll go ahead and write down what we've got for the answer for this. All right, so for I in range 4, because we're going to be choosing 4 random words, right? So word is equal to random dot choice of our options. So we choose a word randomly out of our options. We'll need an accumulator as well. Again, password is equal to blank, and we just simply say word or password plus password is equal to password plus word print password. Join, decrease, modify, insert. Asian Express escape improved. Tap appeal, call me mine. Extra burden, claim dot. Right? So we've got our random 4-word passwords over here. Now, the next section really isn't too much because we can just simply, all we need to do is just simply to make it capitalized, all we do is just simply add in this. We say word is equal to word dot capital, let me see. Yeah, capitalize. Word dot capitalize. And what that will do, if we do this now, is we get it in camel case. Invest language acquisition shared. Data acquisition shared. And if we wanted a new word, we just simply add it in there. Okay, now the last part's actually kind of the most interesting part in my opinion. And because it goes well beyond what this exercise generally entails, but it's fun because it's all about password breaking. Let's suppose that you basically have a weak password. And by weak password, I mean a 4-letter character password, and it's only made of lowercase letters. Say like you had your password and it was snap, okay, or done. How many guesses would it take you to guess the password? You can actually write a program to create 4-character string and compare it to the known password. So if we put the process inside the loop, we can track and see how many guesses it takes. So here, right, let's say the password is ABCD, right? So what we're going to do is we're going to count our guesses. And then what we've got here is the other type of loop called a while loop. Now we're going to go into more detail about while loops later, but there's 2 separate types of loops in programming languages. The first type of loop we've learned about, and that's called a for loop. And what a for loop is that it's also known as a definite loop, because you definitely know when it's going to finish, right? For a for loop like this over here, for I in range 1, if range 4, how many times is it going to run? It's going to run 4. If you say for I in range length or some other variable, it's going to run a definite number of times. In other words, it's going to run how many ever big this, whatever the value of this number is times, right? You can definitely figure out how long a definitive loop is going to run. Over here, with a while loop, we can't say exactly how long it's going to run. It's a lot like an if statement. It takes a Boolean, but it keeps looping through it while the condition is not met. So while not done. So notice that done is false, so we say while not done, that's true. So while true, it's going to keep going and going and going until done is equal to true. Then we'd get not done, which would turn into false, and then it would stop it. So here, what we're going to do is that we're going to try to guess this password and count how many guesses it takes. So I'm going to walk you through this one since it's a bit more of a challenge. But notice this if statement over here. If guess password is equal to my password, found it after this many tries. So first thing we want to do is that each time through the loop is going to be a guess for us. So we'll go ahead and increase guess num is equal to guess num plus 1 to count how many tries it's going to take for us, right? And then over here, we got to figure out so let's see, we've got import random, which we're going to need for randomly choosing things. We've got a sys.set execution limit to 60,000, which becomes 60 seconds. So in other words, this is 60,000 milliseconds. He's got the password. This is the password we're trying to match randomly. Okay? So these things are just basically to make sure that the program doesn't stop running while it's still working. So how long will it take? Well, let's go ahead and just do this randomly rather than a methodical way. Okay? So let's go ahead and say alphabet is equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now I know my ABCs. So I think that's everything, right? Whatever, it's got A, B, C, D in it, and that's really all that matters. So the premise here is that basically we are going to say that we've got a variable here called guess password. So we are going to choose 4 letters at random. For I, does that make sense so far? We're going to choose 4 letters at random from this. For I in range 4, and we're going to use exactly what we've been doing previously. So letter is equal to random.choice alphabet. So we're going to randomly choose out of this alphabet, and then we're going to add it to guest underscore PW is equal to let's just say plus equals letter. That'll tack it on to the end of there. And then if we run it, error, bad input on line 12. For I am range 4. What did I do here? It's all my fault. I know. What? In range. And now found the password after, whoops. Found the password after 16,000 tries, it said. So load history. So that's how you load stuff from your box over there. Save and run. See, it's still going because it's a completely random thing. Okay. The web page is slowing down your browser. What would you like it to do? Wait. It could take a while. It's also possible because it's completely random that it never guesses A, B, C, D. Wait for it. I know. Sometimes it's hard to tell whether it's doing something or not. So one way to get around that is to insert more print statements in there and print every time that it's like a multiple of 1,000 to do that. All right, so, oh, there we go. Found it after 620,000 tries. Took it 620,000 tries. But notice that to crack, so that felt like forever with me sitting on there and my computer nagging me for this password, that this password generator is going to slow everything down. Okay? But really, it's not that long at all. It took, because this was 4 characters, it took this many tries to do it. Took, let's say, about a minute. Now, for reference, when if I were to add another character onto here, basically what it's got. So how long would it take if I increase the length for 25? Well, there are 26 letters, so there's 26 possibilities for A, 26 possibilities for B, 26 possibilities for C, 26 possibilities for D. So in other words, there are 26 to the 4th possible combinations. That is how many possible 4-letter passwords there are. Now, because this was completely random, by the way, I just simply got unlucky and tried a bunch of the same passwords multiple times because I wasn't doing it in a very methodical manner. I was just randomly trying passwords. Okay? But if we were to increase it to another letter, then it would be 5 letters long, which means that how many possible combinations are there? Well, there's 26, 26, 26, 26 for the first 4 letters, and then the next letter has another 26. So it takes that many. So in increasing it so it basically multiplies it by 26 tries. So if our first run takes 26 minutes, then, let's see, if it takes 1 minute to crack a 4-letter password, then it'll take 26 minutes to crack a 5-letter. It'll take 676 minutes, or 11 hours to crack a 6-letter. Or 292 hours to crack an 8-letter or 7-letter. So, and again, this is if it takes a full minute, and we're not. And remember, I'm running in the web browser using it completely at random, right? If I run this again, it probably won't take as long. Although now it's still asking for mercy. So just keep that in mind that these take. This is running in a web browser. It's not super efficient. If I tell it to, if I stop it instead, right, I'm going to copy paste this because that's what I'll do. And now I'm going to go over here into Guinea. And here we go. Boom. And pw crack.py. And now let's go ahead and just run it over here on my laptop, which is not on a web browser. There's no attribute limit, right? This is not something that we need because it's something specifically for the web browser. Run it. And yeah, it went through 100,000 in the blink of an eye. It didn't even take a couple seconds. This one's taking a couple seconds. Right? So cracking a 8-character password just by doing it randomly is not that hard. But if you just use lowercase letter and expand it to 26 letters, even if it takes a second to crack, if it takes a second to crack 4 letters, it will take, I don't know, trillions of years, more, much more for like something 16. These numbers get big fast. So use big passwords. The only way you can, use big passwords. So go ahead and turn in basically the word password generator you did. You'll want to go to Canvas. Right? Go to Canvas. And go ahead and turn it in. I'm going to go ahead and publish the next exercise we're going to do, which is a whole lot of fun for me because honestly, it's a tricky one. So upload basically the part where you're working individually on it to the XKCD password. It's under assignments, under quizzes, and in-class assignments. The one with the words. Yep, you just submit what you had over here, and I think what it is that you can copy and paste it into a text box, or you can just upload a file or whatever. You copy and paste, turn in this one over here, the one with this one over here with the nouns, verbs, and adjectives. The one where you were working by yourself or with friends. Okay. Number 2, yes. So, yes, the second exercise. All right, so let's go ahead and start my most infamous in-class exercise, Blame the Pope, which is, I know, sounds very anti-Catholic, but I'm not talking about the current Pope. I'm actually talking about Pope Gregory the 13th specifically. So specifically, we are going to be blaming him because we use what's called the Gregorian Calendar. Now, if we look at, so let's go ahead and just look at the Wikipedia article for Benjamin Franklin. And I know it seems like, wait, Pope Gregory the 13th and Benjamin Franklin, what do they have to do with each other? Pretty much nothing, except for the fact that Benjamin Franklin was born before the institution of the Gregorian Calendar. Notice over here that it says, for Benjamin Franklin's birthday, it says, birthday, January 17th, 1706, OS, Old Style, January 6th, 1705. Wait, what? What? Old Style, New Style dates. Calendar convention. That was when we went from the Julian calendar to the Gregorian calendar, and that causes all sorts of stuff. By the way, people change calendars occasionally. Like every couple centuries, we might come up with a new calendar. So that makes it a bit of a pain. I highly recommend you watch the video at some point that's linked into this in this assignment, Blame Pope. This is an excellent one. But anyway, what is the premise of this assignment? The premise is we are going to write a program that, given a string as an input, we are going to test whether the string is a valid date under the Gregorian calendar. Your program should output whether the given date is valid. If it's not valid, tell me why. So what's awesome about this is that it is equally difficult for everybody. It doesn't matter if you're new to programming or not new to programming. It really doesn't matter. There's no loops involved. It's all pure logic. So let's learn about the way dates work in the Gregorian calendar, which is, of course, named after Pope Gregory the 13th. It was commissioned by Pope Gregory the 13th, and a number of countries didn't use it until like the late 1900s. So that causes all sorts of nonsense when you're trying to compare dates. So dates in the U.S. are formatted month / date / year. So we're going to assume that's how they're going to enter it. 2 digits for a month, 2 digits for a day, 4 digits for a year. They're going to input it all as one string. Valid months are in the range of 1 to 12, inclusive, right? No 0 month, there's no 13th month, there's no February. September, April, June, and November are all the months that have 30 days. All the other months have 31 days, right? Except for February. February is unique because February has 28 days on a non-leap year. Okay? So notice that basically before we read on here, we've got a couple things to do. First, the year is going to be valid no matter what the number is, right? So long as we enter in 4 digits, it's going to be a good number. Okay? Even if it was negative, to be honest, it'd still be a good number. Okay? Next, the day, if it's above 31, you can automatically just throw it out no matter what. But if it's like in September, April, June, or November, you know to check, is the day valid from 1 to 30. If it's not that or February, then you know, let's try something other like 31. And then you also know that the month has to be 1 to 12, right? Before we get into the nonsense with February. February, though, we're going to have to treat like a very, very special case, because February has 28 days, except on a leap year, like this year, where we have 29 days. February 29th is on a Saturday. Okay, leap years, as I've mentioned multiple times in this class, are not as easy as you think. A year not divisible by 4 is a normal year. If it's divisible by 4, it's a leap year, except a year divisible by 100 is not a leap year. Except if it's divisible by 400, in which case now it is again a leap year. So, for example, 1644, totally a leap year. 1645 is not, because it's not divisible by 4. 1600 is a leap year because it's divisible by 400, but 1700 is not because it's not divisible by 400, but it's divisible by 4, but not 100. Ooh, the logic is kind of weird here, right? So the year 2000 is a leap year, 1900 is not a leap year, 1800 is not a leap year, 1700 is not a leap year. So you only get to be, so only every 4th century is a leap year. Centuries are not leap years. That is the exception to the rule. So if you're alive for 2100 and people start thinking it should be a leap year because it's divisible by 4, you'll be able to go, that's what you think. And the laugh will probably be just as creepy because you're going to be old. So, all right. So, now we're going to need so I'm going to lead you through this step by step, because trying to piece this together, this was something I used to give a week for, but I think it drove some of my students insane, so you know. So let's go ahead and remind ourselves some of the useful functions we'll need for this. The first thing we'll need to use is to slice a string, right? Which is that given a string, we can use slicing from beginning to end, which is relevant for your exam, to extract a small portion of it. Next, if you want a integer to get a string to get turned into an integer, you throw it into the int function. Finally, the last thing, how do you tell if a number is divisible by another number? We use modulo. So here, let's go ahead and see, how do I tell if a number is divisible by 4? X is equal to 2342. How do I tell if it's divisible by 4? I can ask x mod 4 equals 0. In other words, is the remainder after I divide by 4 equal to 0? No, it is not. What is the remainder after I divide by 4? It is 2. So 2342 would not be a leap year. 2344, on the other hand, is divisible by 4. So equals 0. So that is divisible by 4. Dividing something, modding something by a number, and then asking if the remainder is equal to 0, that's how you can tell if something's divisible by another number, right? Let's look at an easier example. 1340 mod 2 equals 0. That's an even number because it's divisible by 2. If it's divisible by 2, if it's divisible by 2, that means when it's divided by 2, the remainder is equal to 0. Similarly, it's divisible by 5 and 10 because if you divide it by 5 and 10, it's going to divide it cleanly. There's going to be no remainder. So when we get to the February portion, we're going to be using modulo 4 and modulo 400, right? So let's go ahead and start this out, though, without worrying about February. February is a nasty thing. So we're going to go ahead and just look at it without it. And we'll be working on this in portions. So the first thing we want to do is we will want to get the input from the user. So let's go ahead and make this pope.py, put it into classroom. I'm going to put it into ITP, fall 2020. Okay. Pope.py, yes. So first thing you're going to want to do is take input from the user, right? So input, right? That's please enter a date, a valid date. Boom, boom. Date is equal to boom. The next thing we want to, so let's think about our tasks as to what we have to do for this. So the first task we have to do is take this string and split it into 3 parts, numbers specifically. We need the date portion. This date is going to be in month slash yy, sorry, month slash day slash YYYY format. So we need to split it up into those 3 formats. You don't have to use the split function or anything. You can just use slicing, right? I didn't teach you the split function. So the way you should approach this is to slice this up. So that's our first step. Next step is figuring out if it's a valid month. Because once it's a valid month, that's the point where we have to worry about the day. Okay? So for our first step, we're going to work on right now, individually, individually but with your friends, without me. Split this string up, this input valid date, into 3 parts. Okay? And then print those parts individually, right? Like the month is blank, the day is blank, the year is blank. Okay? So split it up into the 3 parts so that we can check, so that we'll be able to check each part. Yes. Yes. No worries. If you need a lead, this is the me help you out here with the indices in case you, right, 0. Gesundheit. Now remember, we're going to assume that everybody's entering these dates as the numbers in this format. We're just going to including the we can ignore the slashes. We're more interested in the dates. The slashes are easy enough to retrieve if we want to. The dates are the more complicated portion. All right, 2 more minutes, and then I will bring everybody up to the same place. All right, so I'll go ahead and just get everybody up to the same speed on this part. So, right, month is equal to, just simply all we have to do to get the month is to get the first two numbers. So it would be int, because I'll need these as ints eventually. So if you didn't put int, just go ahead and put an int around it now. It's going to be int date, and then we need the character starting at 2 up to, character starting at 0 up to, but not including index 2. And you know this is going to be right because it's going to grab the first 2 characters, because remember, 2 minus 0, the end minus the beginning, gives you the total number you grab. So right, this goes up to, but does not include. Copy, month, day, year. So the year is just going to be 6 all the way up to the end. So I'm just going to put 6 to the end for my slice. And then for my day, that's going to start at index 3, go up to, but not include index 5. So insert 3, 5. And now we can print month, comma, day, comma, year. And this allows us to kind of just confirm that, that this is what we need, right? If I type it, so if I type in 13, 14, 1982, right? We're not checking yet. Then it's gonna, but we've successfully extracted all 3 parts of it. Okay. So 13 is not a valid month, so that should be probably the first thing we should check. So basically, there are really what this is that we've got a bunch of if statements that need to happen. Because there's a bunch of possibilities. Let's just examine the month first, because there's a bunch of possibilities. The year's not going to come into play unless it's February, believe it or not. We ignore the year unless it's February. But for month and the day only matters based on what month it is. So the first thing we have to look at is the month. So there's a couple of different possibilities, each represented by an if statement, which you'll have to figure out. So the first thing is if so I'm just going to keep writing if true over here, just so that you can, even though that's going to be absolutely useless, you're going to want to replace the true with what you've got. So if it's a day with 30 months, sorry, not 30 months. If it's a month with 30 days, we'll want to handle that one way. That's one category, right? And I'm just going to put pass there. Pass is a special word which says, yes, it's an if statement, or yes, it's a for loop, but I'm going to fill it in later. So please pass it by. That lets me fill it in later, so you're going to want to replace the pass later on. We'll need another statement. Otherwise, if it's a month with 31 days, pass. Else, if it's again, you're going to want to replace all the trues. I'm going to get to your next part in a second. So if it's not 30 days and it's not 31 days, then that means it is February. And then the last condition is so if it's not a month with 30 days, it's not a month with 31 days, and it's not February, that means it can't be any of the months that we want. So we just simply say, we'll let the user know they didn't input a valid month. So your objective right now is to fill out the if statement over here, the if statement over here, the if statement over here, but not the body of the if statement. So we don't have to do anything yet. Just simply say, replace the true portion for each of these, right? So replace the trues, not the passes yet. Make sense? Right? So make it so that the comments are true. And for those of you who did not grow up in the United States, I don't know if it's easier for you to remember. And for those of you who can't remember that silly rhyme, here you go. September, April, June, and November have 30 days. September, 9. April, 4. June, it's like 6, yeah. And November, I think that's 11, right? So those are the months that you're going to want to check. So, okay, so go ahead and fill these things out. I'll be around to help you out. So fill out the if condition, but not the whole block yet. Yes. Excellent question. So if I entered in, so if it was 0, 1 that was entered in, it would just be 1 after being converted to an int. Okay? Remember, you're here because I didn't realize how tiny it was. September. There we go. September, April. So what does the condition look like for it to have 30 days? So don't overthink it. So if the month has 30 days, how do we know it's based on the month? If month is September, so if month is equal to 9, or month equals to 4 for April, or month equal, and so on and so forth, right? That's how you should be handling it. It's not, don't overthink it. Also, by the way, this is a double equal sign. My font just glues it together. Yeah. Yeah, you have to do month equals for each of them. Yes. Sorry? No, because the day is what's been in is because the day could be something, could be 1, it could be 2, it could be 3, it could be 4. Yes.
Can we just do 9, or do we have to do 0, 9?
You can just do 9 because after it's converted to an integer, it will chop off any zeros that are in any leading zeros. And if you were to put 0, 9, it would just convert it to 9. What? Oh, it just means that we're going to fill it in later. It means skip it. It allows me to write code that compiles that. If I don't have something there, then it's not going to work properly, not going to read that properly. So I have pass there. Pass it. Yes.
So the next part would just be the same thing?
Yep. But with the different months.
Yeah.
Maybe seem tedious. If it feels tedious, doing month equals. Copy paste is your friend here. What's the issue? Since we have about 20 minutes left, I'm going to go ahead and push us forward. So if month is equal to 9 or 4, or month is equal to 11, right? Or month is equal to 6, then those are months with 30 days. I'm going to go ahead and grab this guy, move him over here, and just put it in order. Yoink. And just going to order it numerically. Okay. So if month is equal to April, June, September, or November, those are months with 11 days. Those are months with 30 days. Okay. Also over here, February, that's pretty easy to figure out. That's month equals 2. So if the month is 2, then congratulations, it's February. That's all we need to do. Finally, a month with 31 days, that's every other month. So it would be month equals 1, or month equals not 2, 3 is not listed yet, 4 is listed, 5 isn't, or month equals 5, 6 is listed, 7 is not, or 8, so month equals 7, or month equals 8, 9 is listed, 10 isn't, 11 is, 12 isn't. So the months with 31 days are January, March, May, July, August, October, and December. Okay? Otherwise, we don't have to do much here. We can just simply print month, str, month, plus is not a valid month to complete that statement. Didn't tell you to do that, but now that if we do that, I can kind of just show you, hey, enter a valid date, 12/34/1999, doesn't give me an error. But now if I enter a bad month, such as the 72nd month on the 31st day of 1901, it'll tell me that 72 is not a valid month, right? Now for this part, it's fairly straightforward. Now for the next part, let's work on checking the days in all the months that are not February. So over here, I basically need to do another if statement. The month is 4, 6, 9, or 11. That means that it's got to have 30 days. So it's got to be 1 up to including 30, which is and that's inclusive, right? So we just need another if statement over here. So if, and over here we'll just simply do true. If this is basically in range, or rather if it within 1 to 30, print valid date. Else, print day, let's see, str day plus is not valid for plus str month, right? So that's really all we have to do to detect. Basically, we ask ourselves, hey, is this within 1 to 30 days? If it is, great, print out that it's a valid day. Otherwise, well, if it's not in the good range, we can just simply say it's not valid. And by the way, Professor Rosen, you forgot a closing braces, so we should put that over there. Okay, so now, and this will be the same thing, except we'll be changing whatever we check for 30 for 31 over here. So go ahead and complete these two. So work on completing these two blocks over here. And all you have to do, again, is finish this if statement over here, which is check that the day is within 1 to 30. Inclusive. Remember, there is no day 0. Is that a video game? Day 0? It sounds like a video game. Day Z. Alright. This one's not too bad, so I know I didn't give much time, but really it's just as simple as this. If 1 is less than or equal to day, and again, this less than or equal sign, that's just my font doing some really cool things. If 1 is less than or equal to day, and day is less than or equal to 30, which by the magic of Python we can actually condense into this statement because Python's amazing like that. Right? If 1, this is valid in Python, and again, so I use a font called Fira Code, F-I-R-A. Fira Code is based off of Fira Mono, which was commissioned by Mozilla, which is behind Firefox. So for a operating system they worked on and then abandoned. So they wanted an official font, and the fonts were really nicely designed, and then somebody took this and added ligature functionality so that I can get really nice. So this is something that people are either like, I love this, or people are like, I hate this. Either approach is fine, but I love it, so so you're going to suffer with it. That's really all we need to do for this one. And then to get this one over here, we just simply take boom, boom. If 1 is less than 31 over here, right, because these are days with 31 months, then all we have to do is this one. So now we can run this and say, hey, is this a valid date? 12/31/1999. That's a valid date. If I say 11/31/1999, it's going to say 31 is not valid for 11. So 31 days is not valid for November. I can also say, hey, 30, let's go with 11, 20, 11, let's see, 28, 1933. This is, of course, going to be valid because it's within the range. So let's talk about February. So let's go ahead and get some stuff out of the way. We only care about the year when it's a leap year, and we only care about the leap year under certain conditions. Namely, first off, we know that if day is less than 1, print, we'll just go ahead and grab this text that I've been using. It's not valid for this month. Okay? We also know, and I'm just going to break this up into else if statements, even though there's a bit of there's ways I can combine some of this. We also know that basically, right, regardless of whether or not it's a leap year, if the day they input is more than 29, right, then it's not a valid day, right? So I'm kind of doing the opposite of what I was doing. I was kind of just, here I'm trying to, here I was checking is it good, here I'm checking is it bad first. Sometimes it's easier to check if it's bad. So if the day is less than 1, or if the day is greater than 29, in fact, let's go ahead and say, or day is greater than 29 up here. And we could possibly rewrite that, but honestly, I just feel this is the cleanest way. So if the day is less than 1 or the day is greater than 29, doesn't matter if it's a leap year or not, it is bad. Else, if day equals 29, that means it's a leap year. That's our doom. That means that we basically are doomed and have to do some really nasty logic. Okay? Or we have to check if it's a leap year. Else, so if it's not less than 1 and it's not greater than 29 and it's not 29, then it must be 1 through 28, just by pure logic. So we can say, hey, print, and we can print out valid date because it's valid. We know it's valid. If we're in February and it's not one of these conditions, then it has to be 1 through 28, which is all valid on all Februaries, including leap years. It's only 29 where we care about it being a leap year. So that's where our logic gets us. So let's go ahead and start. I'm going to start you out here, because we're going to need a couple nested if statements. Because the first thing we need to check over here is whether it's potentially a leap year or not, okay? First thing we have to check is whether potentially it's a leap year or not. So we know the day is 29 in this block, if we're in this. If year is divisible by 4, then it's leap year. Actually, no, it's not. If it's divisible by 4, right? We went into this. It could be a leap year. It's probably a leap year. In fact, in most cases, it is a leap year if it's divisible by 4. But if it's not divisible by 4, we know it's definitely not a leap year. So now, in the last couple minutes of class, I want you to try to tackle this logic over here. Actually, with 7 minutes, I don't think we have the time to try it individually, so I'll just simply run you through it. Unfortunately, we're just stuck with time constraints, and I don't want to do it next period, and I don't want to leave you unsatisfied here. So, we can't really just check if this is this pass isn't sufficient for us to say that it's valid or not. We also have to check, hey, is this divisible by 100, right? If year is divisible by 100, so if it's divisible by 4, it's probably a leap year. But now let's check, is it divisible by 100? If it's divisible by 100, then it might not be a leap year, right? We can't say for certain still. But if it's divisible, but if it's divisible by 4, but not divisible by 100, we can actually say it's a leap year. Print valid date, right? Notice how weirdly this is nested over here, right? If it's divisible by 4, but not by 100, right? If this passes, it's divisible by 4, but it fails this check, that means it's not a leap year. Sorry, it means it's not divisible by 100, therefore it's a leap year. It's a year that's divisible by 4, but not by 100. Okay, now we're back over here, inside here. Well, if it's divisible by 100, it means it might not be a leap year. By the way, there's other non-messier ways to do this, but it's just kind of, I'm trying to pluck it at one strand at a time, right? If it's divisible by 100, we're still in that maybe condition. Because if the year is divisible by 400, then it's a leap year. But if it's not divisible by, but if we get here, it's divisible by 4, it's divisible by 100, but it's not divisible by 400, that means we're in a year like 1900 or 1700, which is not a leap year, so we have to print out 29 is invalid on non-leap years. Invalid. Look at that beautiful mess we just made. Right? This is kind of amazingly awful. Leap years are complicated. But there are other ways to do the logic here to make it a bit easier. First, to check if the year is divisible by 400 first, and rule it out that way. Or you can combine these into AND statements, right? If it's divisible by 4, if it's divisible by 4 and not by 100, then yes, it's a leap year. If it's otherwise, check if it's divisible by 400. Right? There's other cleverer ways to do it, but this way made sense as we were working through it. So, and that's one of the most frustrating things about programming sometimes. Sometimes it made sense when you were doing it, but when you finally step back and look at it, you're like, what the heck was this nonsense? Speaking of this nonsense, we should probably check it rather than assuming that it works. 2/29/2017. Yes. Not 2/29. 02/29/2017. 29 is invalid on 9 leap years. 02/29/2020 is a valid date, and 02/29/1900 invalid on non-leap years. And finally, for the year 2000, 02/29/2000 is a valid date because it's a leap year. All right. So please check out your new homework, and I highly recommend you take a look at this assignment, by the way, and check out the video that I have linked here on Computer File. This should give you an impression how difficult time is on computers. Please look into how difficult things are on your computer, and remember to never, ever, 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 ever write anything that handles dates or times. Use a library that somebody else wrote. Never, ever, ever, ever write anything that messes with time, or the time-space continuum. Right? Yes, please upload what you wrote onto the Blame the Pope Dropbox. On the last line of the code. Let me open it back up. Yes.
So you were saying you're going to have the test done by Thursday, right?
Yeah, written by Thursday, yeah.
All right, and I emailed Streetcar if I could take it
Yeah.
Thursday morning. That's still good to go?
Yeah. If it's not,
If it's not, I'll have to take it next
Let-
Thursday.
yeah, let me know.
do the thing. All right.
yeah, just let me
Should I
know.
email Streetcar again?
Yeah, email. I'm planning on trying to write the exam tonight or tomorrow. So. Night. I have office hours at 4. Can you come by then? Yeah. Yeah. If you've got demos, I've got office hours at 4 o'clock.
Do you want us to upload it now?
Yes.
Because mine's giving me an error, so I don't know like what to do with it.
Can you come by office hours?
When is
4?
your- Yeah.
Okay.
Okay. Thank
I-
you.